Hello everyone, and welcome into another live stream. Hi there, Oro. How you doing? How are you doing? Hi there. So, today we're gonna start right away. Actually, I do believe no point in wasting time, and by that I mean, very obviously. Make it what's happened to make it charge scenes, make it movies, and make it research? Well, I didn't have enough time, that's what happened. There we go. Is it in focus? Close enough. This is the supports that we designed yesterday, printed. The only problem is I forgot about tolerance, so popping them in would actually be a major pain. So we're gonna throw away the front for now, we're gonna remake it. We're gonna this time change it from 2.5mm to just 2mm for the sake of tolerance. Because we're trying to be extremely tolerant on these streams. Okay. Oh my goodness. I do have a lot of work to get through today, so I'm hoping that it will go smoothly with no issues whatsoever. Because why would there be any issues? Why would there be any problems? All right, it's all gonna be simple. Okay then. Okay then. In order to update them, actually, I'm pretty certain all we'll need to do is just change a 2.5 right here to a 2. Okay, not 20,000, only 2. Now would 2 be too many? That's a good question. 2 too many, 2 too much. How about 2.3? Yeah, that should be fine. Alright. So just export it right away. And let's get to printing. This is the front, correct? Yes. Let's get to printing. You are implying that Wikichurching was a mistake that contradicts you being God. I'm not implying it was a mistake. I do still have the Doom video to edit. Oh fuck, you're just reminding me of more work. I have so much more work to do. Okay. Print. There we go. Danny will be cooking in the background. Let me also switch to live chat instead of top chat. There we go. Now we're cooking. So that is the first thing we're gonna have going in the background. Second thing, how long did it take you to learn the hydro matter? It's really tough to say. Same with how long it took me to learn programming and all the other things. It's really tough to say because I've been using Blender since the moment I installed it, and like there was no point at which I all of a sudden got good at Blender. I just progressively got better over time. So I would say that my current skills represent 4 years of Blender usage. It's really tough to say how long it takes to learn Blender. To make simple models, that's like a week, half a week. Shading and textures, depending on how good of a teacher you have, I would say also a week. It's quick. Same with geometry nodes. No nodes in general. I started and I despise it. Oh no! Why do you despise it? Do you want to do organic or structural kinds of models? Or are you not modeling only for... I can help you if you want. I can do my best. There is a lot in Blender. It's extremely overwhelming. But, hold on. Let me have a think. Where are we, by the way, animation-wise? We did 450 to 4100. Oh yeah, but with this ones, I'm an idiot. We didn't need that, we needed them to be in a hexagon. Should I do hexagon procedurally? I'm not going to. End of sentence right there, actually. That was the entire sentence. I'm just gonna eyeball it. That's pretty shitty hexagon. Okay, there we go. There we go. There we go. Now let's set this. Transform, randomize transform, and just rotate them randomly. Yeah, there we go. That's something. This will be our benzene. Hi, the Clowny. Hi. What are you doing? Well, right now, Danny is printing. I am setting up an animation, and then once I'm done with the animation, once it starts to render in the background, we'll open 3 packages I have with more technology and such. So now all we need is icosphere. I feel like we should add the electron clouds later on. So now we'll have this. Not hue, I'm an idiot. Saturation, obviously. There we go. Now 5. This. This. And this. And this. There, I should, I suppose, keep it in a collection. That would probably be a clever idea. There we are. I'm still getting used to the fact that Danny does like a stretch before printing. Or like a warm-up, whatever you want to call it. Splendid. So this should be it. Render animation. Alright, it's rendering, which means now we can get to the boxes and packages and such that I have. Because I have 3 of them. This is such a mess. Okay. First, let's move the mask. Oh, it looks so lovely, doesn't it? It does look really lovely. I am incredible. Let me just move it to the side. The back support we don't need for now. This, the soldering iron we don't need for now. So I'm gonna just pop it into my toolbox. My toolbox is a shelf because nothing here makes sense. Oh, there's my audio amplifier, which we tested. That's great. Oh, foreshadowing. You'll see what I mean in a second. Saddle foreshadowing. Big boy speakers. I'm gonna put this aside for now. Okay, yeah. This should be good-ish enough, I'd say. There we go. Alright. So first things first, we have the first box. Hold on. I almost dropped my mask again. I really need to put it in somewhere else, you know? It gets in the way. You know what I'm saying? There we go. Now it's off. So there we have the first one, which are the connectors. Yeah, these are the connectors I meant, by the way. This, effectively just cables with standardized connections on one side. Right here, I really like the idea of these ones because they just have a whole bunch more of them, which will be really convenient in the future in case we need to send a bunch of data over. This is an LED strip based on the LEDs we've been using, and this time this strip should work, which is good. And this is just a box of the same kind of connectors. Yeah, that's nice. There we go. There we have the box. Let's put it aside. And then what? Well, then we have the next one, which is this one. That's comically small box. Can you believe it? They are actually shipping small things in small boxes. And that is the LED strips. Oh no, they are just the PCBs. I need to solder the LEDs on myself. Fucking hell, you are unreal right now. Do I genuinely need to solder them myself? Oh no. Hold on, I just need to... Got a bit of a message on the side. Give me a second. Okay. Alright, that is all sorted. I am back. Do I genuinely need to solder them on myself? That's ridiculous. Why? These are just PCBs. Let me show you. Hold on. That's ridiculous. Look at it. Well, I wasn't aware I was buying them from fucking IKEA, you know? Oh, you are... And this doesn't even include the coupling capacitors. What? I am beyond just... What do you mean? Genuinely, what do you mean? Ah, damn... Fine, I'm fine is what I am. You are... joshing me right now is what you are. There is... Whatever, fine, I'm just gonna leave it there for the future, just in case we need it. It's fine, I don't even... I don't even care. What was the last one? Last one includes a whole bunch of paper. Convenient. Okay, this right here is a... Oh, these are the cool ones, right. These three, you see. Oh, and I even got some candy. I'm gonna probably put it in my candy box. I do have a box for all the candy I've got from when I ordered all the electronics. Yeah, okay, gets you parts and traction tools necessary. Yeah, in this case, we don't even have the decoupling capacitors, which means we're gonna need to solder them on. Like, I have capacitors, it's just that they're not the SMD ones, which means what we'll need to do is we'll need to use the, if I'm not mistaken, THT capacitors on an SMD board. This is a joke is what this is. Whatever, fine, it's gonna be exhausting, but fine, I'm gonna put it aside for now. You see, we got these three things, which are actually important. That's because they are my I2S microphone, I2S audio amplifier would seem, and I2S audio decoder it would seem. So which is nice, that's good. So these are all the things, packages and such we have. And as the entire beginning of the stream, I'm not gonna lie, I am severely disappointed that the LED strips did not come pre-assembled. I'm genuinely just beyond whatever. Right. I'm just gonna work on the video. What does pusillanimous mean? I'm not familiar with that word at all in the slightest. Couldn't help but notice that there is only one orbital there, not orbital, nuclei. Jeez, I need more coffee. One nucleator. Why is that? Ah, that's why, of course, obviously. I didn't delete the keyframes. That's why. We need to control Z our way till we get to the transform. Nope, that's all the control. Alright, don't save. Start over. Yeah. Whatever. That's the version. Although, I do have to say, you are... Okay, I don't want to say the most, because that could be inaccurate. But you are a strong contender for the most pretentious person that's ever been on Cherry Checkups. I don't want to say the most, because that would be going far, but you are a very strong contender. There we go. There. Now we need to delete all of the keyframes because they just have to be there. Beautiful. And then we should give them random rotation just so they wouldn't look so weird. Beautiful. Now this should work. Splendid. Okay. There are a lot of things I need to do this stream, but I'm going to start the most important ones. What I want to do is work on the mask mainly. But unfortunately, there are certain things that are more important at the moment, and that is finishing the video because I haven't uploaded a video in 2 weeks. So what we need to do is ideally script up the ionic segment. And I'll be brutally honest, I don't know terribly much about ionic bonds. I've dealt with them a bunch of times, but in comparison to my metallic bonds knowledge, it is very lackluster. So what we're going to do is very obviously look up library text, muscle memory. I just muscle memory moved the tab to the other screen just in case. But library text and then resources, libraries, chemistry. And what we're looking for is what would be related to ionic. That's a good question. Inorganic, I'd imagine. I will probably most of it leave for the next video. That's because we're supposed to end this video on intramolecular stuff. Coordination complex. I find it quite simple. Okay. What else? Yeah, no. Not exactly what I'm looking for. That's a good question. What would ionic bonds be in? That is curious. We're going for something specialized to ionic. If I just look up ionic, I will probably get general chemistry textbooks. And just individual chapters from them. Organic chemistry. Well, I got my face. Yeah, but that's in fundamentals. Anything more? No, we just get... equivalent. We just get a single chapter on ionic. Ionic solids. Alright, let's see. Combination number cutting core. Okay, so the ratios, gotcha. Yes, sorry, crystals. Okay. Okay, general chemistry, as I said. And this is for solids. Crystalline. I guess we'll need to do a bit of a dive. Like, not a deep dive, let's not call it a deep dive, it's not even close, but a bit of a dive. That would be probably the best way to go about this. Before we do, however, let me just quickly check. Where do we stand on the benzene? Oh, we haven't actually gotten to the metallic bonding yet. Okay, we're almost there. We're right here. For example, in benzene, where the atoms look like this, so carbon is bonded to a hydrogen and next two carbons, like this. Except those are the SO atoms, and the two p. Okay, last bit. So what they do is they all just merge together. This is going to be an absolute pain. Alright, bye hello, bye, have a good one. It's going to be an absolute pain to make. That's because we'll need to do it with metal balls, actually. We do already have the p orbital made of med balls. We already modeled that. So we'll need to just... It just hit me how loud Danny actually is, you know? I need to speak up. I need to speak up a bit louder. There we go. That will hopefully wake me up as well. For some reason I'm just... Okay. I haven't drunk anything in like 4 days, 3 days? And when I say something, I don't mean water or coffee. Or tea. I mean lemonade, of course. Now, let's make sense. So, let's get to it. Semiconductors and insulators, that's comical. I think crystalline solid structure might not be quite it so far. That could be for the next video. That could include crystals, because that would be a pretty good segue to states of matter in my personal opinion. But intrinsic solids, ionic solids, this is going from something slightly different to what I want. Ionic bonding, right, let me see. Oh, ew, UK? Oh, University of Kentucky. Alright. A whole chapter on ionic bonding. Let's see it. Ions are atoms of molecules which charge cation the compass goes in the common souls because I had to get by anyone because like for destruction being solids solids however dissolve readily in water. Once dissolved or melted, ionic compounds are excellent conductors of electricity and heat because the ions move out freely. Yes, there we go. Neutral atoms and restricted ions have very different physical and chemical properties. Sodium atoms from sodium metal. Sodium atoms form sodium metal, a soft silvery white metal that burns vigorously in the end reacts with water. Chlorine atoms form chlorine gas, a yellow-green gas that is actually corrosive. Most metals are represented. The vigorous reaction between sodium and chlorine forms white crystalline compounds. Yeah, table salt. Alright, gotcha. Okay, so then we have deformation. He hates UK. I don't exactly hate UK, it's just that it upsets me when people think that it's real, like a real place, when it so very obviously is not. Okay? UK is not a real place. And I'm just trying to, you know, fix the world, rid it of misinformation. This is all I'm trying to do. Many metallic elements have relatively low energy potential. These elements lie at the left period or near the bottom of the group period table. Okay. Metallic elements have relatively low ionization potentials and lose electrons easily. That makes sense. That does make sense. Will there be anything interesting about ionic bonding that I would be able to find? Because so far we've been going from quantum mechanics, and I would be brutally honest, the main reason why I don't know quite as much about ionic bonding as I know about metallic is because I have learned chemistry from quantum mechanics, like from the scales going up. And so ionic bonding is always explained with the typical charges sort of thing. You know, negative charge, positive charge attract each other. And they never really mention any underlying quantum mechanical properties. Condensed, because very free ions. Okay. Does not present the physical arrangement of ions. It is incorrect to refer to sodium chloride molecule because there is not a single ionic bond between any specific pair of sodium chloride atoms. The attractive forces between ions are isotropic, the same in all directions, meaning that any particular ion is equally attracted to all nearby ions of opposite charge. This is interesting. There we go. We got something. Alright, there we go. The diagram isn't there, but well, we'll make the diagram today, so. Okay. Oh, we could even do it with Manim. We could do it with Manim. Oh, we could even try to do it with Blender, I suppose. Blender controlling positions of instances with Python. Could I do this sort of thing? Because that would, not gonna lie, that would make this way easier. Because effectively what I'm trying to do is I'm trying to simulate them. Which wouldn't be all that easy with geometry nodes. Simulations require a time step, which geometry nodes really do not have. That makes sense first. No! 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 Exporting geometry node into position from expression viewer. A list of positions of the instances of the selected objects. Okay, so we have. Ah! Get geometry node instances. Okay. Oh, we're back. Brilliant. So what we need to do is, well, we need to test this first, some kind of reasonable way. Here's what I'll do. I will create, for now let's do 10. delete absolutely everything. Test. And we will just create 10 spheres. There we go, 10 spheres. And what we would like to do is create an animation where they go forward, where the acceleration of every single one of these spheres is dependent on their index. Now, the crucial thing here is that I don't want to do it with typical math equation. I want to do it as a simulation, which means what we need to do is go to scripting, and we need to somehow access these instances. So let's see this first of all. What does it do? This graph by PR context evaluated this graph get. But I'll need to figure out what that means first. So let me just, can I comment all this out? Oh, the shortcut works. Oh, that's lovely. Alright. Import BPY and print me this. I should really look up what it does instead. I was honestly expecting. Hold on. There's got BPY struct. Status and first taking into account. Okay, so that's dependency graph. Why is the FS in there? Not understanding a name of something is usually a dead giveaway and I'm gonna struggle. Access to evaluate ID is object manager, so just state from the original ID. Every time one needs to access state of the animation, constraints and modifiers taken into account. Okay. So right here, we have this. Let's also create the cube right here. And then let's try to create this. Okay, that didn't copy. There we go. Do you think it's possible to create Antim? What do you mean Antim? What is Antim? Okay, object cube evaluated. Alright, so we, oh wait, so we just evaluated. I'm not gonna have fun, am I? Alright, let's create the evaluated object. For some reason the copy is just not working. There we go. And then print depth graph object instance invalid. Brilliant. Quick question, do we have 10 of them? Because if we have 10, that's a start. Okay, that's good. We do have 10 of them. What happens if we do 15? Ha! Alright, that's something. Because that means we get an array where each entry in the array corresponds to the icosphere or underlying instance. No, because the benzene animation just finished rendering. So right here we need to do something. And that is like this. So right here what we need is we need the SP we need the SP2 hybridized orbital on each one of them. Yeah. Should I do it with met? No, I shouldn't do it with shapes. I will do it with just good old-fashioned meshes. Because we do have these. I'm gonna copy, paste them. Join. No, these three join. Alright, right here you have two of them, which is now one. Oh, brilliant, they're parented. Whatever. Join, clear keyframes. Splendid. This is why I should have done the hexagon procedurally, because now I'm gonna struggle, but the basic idea is we want all of them to have these kinds of that's a good question actually. We want a single image first, then we're gonna place it on, we're gonna connect it to the hydrogen. I mean, I have an idea on how to do it. It's not going to be a great one. It might be even quite terrible. Yeah, I think it might be really terrible. Whatever. It'll be fine. My idea is, we go into the collection. We create a new collection. We call it orbitals. Then we take this orbital, we put it into the orbital collection, and then inside we put the orbital inside of an H, because that stands for the hidden. Then inside the collection we create a new cube, which takes in the collection info, like this, of the orbitals one. And use it for its own geometry. Splendid. Then, can I just do relative and then move it closer? I can, brilliant. And then the reason why we do this is because now we can add a sphere. It's gonna be tricky. Okay. We can do it in a way that's better. And a good way to start would be to name these hydrogens, for the sake of convenience. Okay, this one is a hydrogen. Hi the Dark, how you doing? Hope you're doing great. I'm, as always. How are you doing? Okay. Object info and then relative. I could do it with a switch. That would make this so much easier. If I do it with a repeat node, well, that feels like an. No, this is a good idea. Yeah, index switch, like this, or even better, object. Haha! I'm a genius. 3, 1, 2, 3. Repeat. There we go. Doing well. Glad to hear that, Dark. I really am glad to hear that. Now, the reason why we're doing it in such a silly way is because right here you have hydrogen, hydrogen O2, hydrogen O1. For some reason they're out of order. Damn it. 1, 2, 3, 4, and 5. And now the reason why we're doing it this way is because every single time we're going to join them together, but with transform geometry, increase the scale. Oh, why do you have to increase the scale this way? Okay, scale elements. There. Scale them 10 times, which means now we increase this. Right, like this. There we go. Splendid. Expecting new video in more than 2 days. Probably, yeah. Honestly, probably. We're not that far. Do you think it is possible? With only geometry nodes to create 2 or 3 atoms which affects each other by electromagnetic force? No, and here's where we get back to the original issue. The reason why I'm doing it with Python and not geometry nodes is because with geometry nodes you cannot simulate anything. Because you don't have a time step, which is something you need for simulations. I mean, I suppose you could if you solved it, but that's kind of the whole difference between solving an equation or simulating the results. And in this case, what we need is this. Yup. The only issue being that we index them incorrectly, which means we need to start at 1, then 2, then 3, then 4, then 5, and then hydrogen on its own. There we go. We'll do a hydrogen. Okay, so we'll render another image. Of course, there was something I forgot about. Completely forgot about the fact that right here they need to have a different color. Alpha of 0.9, brightness 5, set material to white, and then the color what this. There we go. Have you decided on the title? No, I haven't. I usually come up with a title and thumbnail at the very end. Although I imagine for this, the title and thumbnail is going to be the exact same as the last one, because it is just meant to be, well, the sequel. Why is this one brighter than this one? They have the same material. Oh no, is the hidden one? No, it is hiding it. Huh. Well, that is curious. They have the exact same shader, the exact same material, the exact same data. And yet this one is for some reason... Why are all of them on the ground? Why are all of them on the ground? That's why this one is dimmer, is because the lower half whatever. It's fine. It's fine. It's not fine. I missed it. It's fine. Shut up. It's fine. Okay. It's fine. It's okay. It's right. It's fine. It's fine. I can just. We'll fix it in post. For now, we're just gonna render it. We're just gonna. I totally didn't notice that they were on the floor. My depth perception isn't quite what it used to be, you know. I still am wondering about one thing, because you know, we're working this in the background, we're rendering. There's still one thing that bugs me, and that is, I keep looking over, and that is the coupling capacitor spot right there, which is empty. There's nothing soldered on it. Can I just leave it empty? The game won't have a coupling capacitor, it's not going to be great, but it's kind of an end of the sentence, don't have really a solution. I'm just gonna leave it empty. Okay, now what we're going to do is we're going to hide the thing, and then right here we're going to add in these on each of the. I don't need to rotate like this, but whatever. I guess I could just do it procedurally at this point. Whatever, it's fine. We're going to... Actually, I've overdone it. We only needed these three. Yeah, we only need these three. And right here, remesh. How do you remesh in geometry nodes? I could do it outside geometry nodes, but I prefer it inside, more control. You already lost me. Too long didn't read. Remesh node geometry, yeah. Mesh to volume, volume to mesh. That's right, that's how I done it. Mesh to volume. A while back ago, for the, I think, was it... it was, I think, the organic chemistry video. Back then, that was the first time I actually seriously did orbitals. And that's why I actually remembered that. That's how I did it back then. The only issue being that this time, for some reason, they still overlap. Why do you overlap? Do I need to realize you? Kind of? No, it's still overlap. Do I need to realize you inside? Oh goodness no. Oh goodness no. Absolutely not. Wait, do you overlap? No you don't. There we go. Splendid. So now we can lower the threshold. Oh, don't lower it that much. Wait, increase the threshold, lower the threshold. Amount. Ah, I see. Amount would be better. 128. Not bad. 15 a little bit. Threshold way lower. I don't really like... This is a pickle. I don't like this. I don't like this much. Because I think it will look like complete and utter shite. Okay, increasing adaptivity seems to help, but then we also need to... Oh, never mind. It absolutely does not help. What about size? I've done it too far. Whoops. Is it because of the underlying model? Oh, it could be because we're not doing because of the volume conversion. I completely forgot about the volume conversion. That's the reason. I'm such an idiot. Yeah, now this one's gonna break. It's because of the volume conversion. Why am I such an idiot? Yeah, alright, we might need to reset. Yeah, close the program. Splendid. Now this I'm gonna guess that the reason why it breaks is because right here we need to increase this. Much better. We can do 256 I imagine. And then right here 256. Yeah. The problem being that normally these would kind of connect down the middle, right? Wait, would they? SP2 hybridized orbital. Or would it just be the conjugated pi? Well, I mean the S orbital I suppose would connect down the middle. Yeah. We are kind of lacking the S orbital in this case. But you know what? Beggars can't be choosers unless they're choosing to be beggars. So let's just run with this. Next one, like this. Here's the molecule. And there we go. So let's do 440, why not? And this time we're going to add all of them, which means, oh yeah, it's gonna be a pain to add with this in the background. Oh yeah, it's gonna be a pain to add. Okay, this is going to be a massive pain to add. We're adding it this way. So instead, how about we just leave them there, turn this off, much better, then parent them to each nuclei, and then what we do is pick up all of the hydrogens, bring them up as the animation goes on, and we need to fix the benzene molecule. So we're going to have this, we're going to have this, we're going to have this, there we go. And then we do need to unfortunately switch to the cube. That's because we need to bring all of the hydrogens close enough. So this should roughly be the distance. Right, splendid. There we go. Benzene-ish. That does not look like benzene. Okay. Brilliant, and then one last thing, which is we would like to probably change up the way we turn into mesh. Just to connect it a bit more. I don't entirely hate this. I'm not getting me wrong, I kinda do, but not entirely. It could be worse. Not by much, but it could be worse. Okay. Let's run the image. Oh, that's terrible. That is utterly terrible. Utterly and uniformly terrible. Benzene is it? It is meant to be, yes. Alright, start there. And right here. Okay, let's try it again. Bring down the activity a bit. Up the threshold. Okay, 0.3. We're getting a lot of very unfortunate geometry. It's how I would describe it. But whatever. How do you differentiate between a single and double bond? Like in chemistry? Well, that's simple. When you have two electrons, a double bond. Or rather, when you have, four. You understand what I mean. In chemistry, it depends on the orbital. And most of the time... You see, I mostly use just molecular orbital theory, which treats double bonds a bit differently. That's because double bonds just means two orbitals connect that do the bonding. So in this case, you don't really have a double bond in this figure. Oh, in this figure, I'm not differentiating between them because there's absolutely no need. Benzene doesn't really have double bonds. It pretends. It pretends to have a double bond. Alright, there we go. That should be fine. It could be a lot worse. I'm gonna leave it there, it's fine. Okay, so now for the test. This right here functions properly when it comes to getting the instances. Blender sets position of instance with Python. Python move object on local axis. Wait, can I just do it like this? Oh, that would be brilliant if I could. Ah, but even then, it's like geometry nodes. Oh, that is a pickle. How would you actually create complex animations? Because I imagine, other than keyframing, every single... I didn't think of this actually. For some reason, I just put that into the back of my mind, just thinking I would figure this out. But like, can you even do it with instances? Blender, Python, change for position of multiple objects to make an animation. I have kind of done it with... I have kind of done it in the computer science series. Okay, so Python won't be all that much more helpful. Blender geometry nodes create a custom node, because I'd be completely honest, not node group, very importantly. Okay. So you can, that's something. Okay. That would be something, but at the same time it would be a complete overkill for what I need. I feel like I should just do it with Monim, because goodness gracious me, I don't have a good way to do it with Blender. All of the ways I could do it with Blender feel so idiotic. Maybe with particles? I mean, I could try maybe a Blender simulation, like a normal one, but I don't like that idea. It wouldn't give me all that much control. I might as well try it. Simulation, there we go. Oh my goodness gracious me, you can simulate in geometry nodes. Never mind, we're fine. We are... Where are we fine? Well, ish. This is much better. You can simulate in geometry nodes. That is orders of magnitude better. Great then, alright. All of you piss off. Here's what we're gonna do. This is still gonna be really rough. Really rough. But we're going to have instances. We're going to create instances like these. Okay. It's gonna be quite rough indeed, but yeah, let's do just a simple one. Here's what we'll do. Set material white and plug this in. In this case, yeah, we just plug these in right here. We're going to need, do we need two sets? There's a capture attribute and attribute statistic. It's gonna be pretty tricky. Like really tricky. Normally the way I would do it in simulation is I would take an object, I would take all of the other objects in the simulation and I would compare their interactions. So I would take all of these interactions, run through all of the objects, and then apply the force or the action, whatever it is, to the object I'm calculating for. And then I would just repeat the process for every single object on the list. In this case, however, since we're dealing with instances, and since we're dealing with attributes, ideally, that complicates things severely. Because we cannot simply take in all of that information. Or can we? No, we can't. No, we can't, no. Or can we? No, we cannot. Yeah, no, we can't. If there was like a node that takes in an ID and gives us back the attribute for that ID, then we could. But we are lacking it severely. Yeah. Hi, the shelter. How you doing? Are you doing organic chemistry? I'm making a video about organic chemistry at the moment. Well, not, I wouldn't say, actually no, I take it back. About chemistry, not organic chemistry. Sorry, just the animation right now is about benzene, but it's not about organic chemistry, no. I am slightly familiar with a couple of things in organic chemistry, but I'll be brutally honest with you, I'm not great at organic chemistry, far from it. I suck when it comes to organic chemistry. Capture attribute would be great, but we can't just run over every single ID, can we? We get position. Like, position, for example, gives us the position of an object, but that's for each instance. Oh, this is rough. I'm struggling a lot on it. Do you have any suggestions for organic chemistry itself? Which parts are you struggling with? I suppose that would be a pretty good start. Like reasons for bonds, IUPAC, functional groups. What specifically? Get attributes of an instance based on ID. That's the only way I can. Accumulate field. Sample index. Yes, that could be it. Sample index. Okay, here's what we're gonna have. Well, here's what we'll try to do. We'll try to create 4. So far, let's keep it. You know, let's keep it simple. We'll try to create 4 icospheres. Habitation node planes in general. Like, how do you mix up atomic orbitals, like X, Y, YZ, ZX, or X, Y2, this kind of stuff? I see. Well, I kind of have an answer for you, but it's not a satisfactory one. As far as I'm aware, unfortunately, in organic chemistry that would be a bit of a memorization game. Because the way it's actually done is you take the underlying orbitals and there is an operator for combining them. But that is not a satisfactory answer. I am painfully aware of that because that's not something you can do on the fly. How should I put this? Like, I can explain how they hybridize and how they combine. And I'm thinking. I think I'm sorry, Shells. I think I don't have a way to help you. Okay. I'm assuming you made a video on the channel, like hybridization. Hybridization zone? I mean, the most recent quantum mechanics video. That's where I ended. But once again, the way I understand hybridization, it works like this. You have... Hold on, let me hide this side. You have your, let's say, p orbital. You have the other p orbital. And then you have the s orbital in the middle. Okay? They can be described with the s wave function, p, let's call it x, and py. And so those are the three wave functions that define them, right? So this s wave function defines the probability of finding the electron on the s orbital, and what we get is the sphere as the shape. My most recent quantum mechanics video explains that. Now, what happens when you hybridize them is you effectively take all of these orbitals and you combine them using the constructive and destructive interference. So that's gonna make me sound like I'm insane, but bear with me. Orbitals are functions which are also shapes, which are also waves, because quantum mechanics makes no goddamn sense whatsoever. But the point is, when you have two orbitals, right, two p orbitals, or let's do it sideways so it'll be easier. Two p orbitals like this, then you can think of it as like two waves colliding. And when you have two waves that collide, let me just show it off in Desmos. Open the graphing calculator, we'll have sine of x, and then we'll have sine of x plus 1, like this. So these are two waves. Then our f of x is equal to this, and g of x. These are our two underlying waves, okay? So these will be our orbitals. Now, when they combine together, they can combine in two ways. Either the constructive wave, which will give us this kind of wave, or the, no it wouldn't, that's meant to be a g, there we go, constructive wave, or destructive. Technically it's due to phase, not subtraction, but doesn't matter. The point is, these are the two ways we can combine our waves, constructively or destructively. One of them is taller, the other one is smaller, that's usually the way it works. Long story short, not getting into ways because I'm already going on way too many tangents. This is how we can combine waves, and when it comes to orbitals, what this effectively translates to is the orbitals, which means that if you take two p orbitals head-on, that means you can get two different ways they combine. You can get the constructive bonding orbital, which would look like this. You can see they combine in the middle. Or you can get the destructive interference, which means anti-bonding orbital, which would mean this. That's kind of what it would look like. The point is there's like a wedge in between them, there's divide, because they interfere and they ruin the bond. And so this is like the simplest example of how orbitals can combine. You take the orbitals, you combine them every constructive and destructive way you can, and what you get is the new orbitals. Hence why the amount of orbitals you put into a hybridized orbital is also the amount of orbitals you get out. Now, with that simple example in mind, let's get back to our hybridized orbital. In this case, once you take all of these orbitals, which means in this case 1p, the other p, and 1s, and then once you combine them all constructively, destructively in all the different ways, what you get is this shape. Now, why do they combine and why does this happen? That's a bit of a longer story, way longer, comically, honestly complicated, but the point is that's why you need the external factor of the hydrogen going in order, well, not hydrogen, but some kind of atom going in from the outside and then bonding them together and then, just combining them together into the hybridized orbital. And would you look at that, we got a methyl group, if I'm not mistaken, if there's a carbon in the middle. So we get sigma and pi bonds, so it's 20 years long. Thanks for your help. I'm really sorry I wasn't able to assist further, Shelza. That is unfortunately all I can say. I'm terrible with organic chemistry, as I mentioned. But if I have some good news for you, because if you like this explanation, then hold on, I need to find it. It's comical because I open. If you like this explanation, then I'm guessing you'll be excited to hear that this is exactly what the current video I'm working on will be about. That's what it will be about. It will be about the ways we combine the orbitals. Like right here, I'm talking about nitrogen gas and all of the. And right here you can see all of the underlying. There we go. These are all of the underlying orbitals of nitrogen gas, which is sigma, antibonding sigma, bigger antibonding sigma, s bond based on the sigma bond based on the p orbitals, and then pi bond, nitrogen. And much more importantly, once you look at it from the side, these are the energies of all of them, where the more something to the left is, the higher in energy it is. So, this should be much more visible. There we go. This is like the graph where you can see sigma bonds are all way low in energy. Sigma bonds coming from the s orbitals. I am not very coherent at the moment, am I? It just hit me. I am very incoherent. But the point is, the lower in energy, the better, because the more stable the bond, and here's how all of them combined. Here's all the possible states. Which is why I am right now rendering a benzene molecule, because, well, benzene is a really, honestly lovely example of the different ways that orbitals can combine, because in this case, it has hybridized orbital with the classic sp2, it has hybridized orbital due to bonding, and it has a hybridized orbital based on the combinations of the p orbitals which all create a ring, which is honestly just basically a perfect example of hybridization as far as anyone's concerned, which is why I like it so much. Now, with that brief tangent in mind, let's get back to the issue at hand. Here is what I'm basically trying to do in this case. First, we need a very, very, very simple test run to see if what I'm trying to do is even possible. And in order to see that, we could have... I don't want to overcomplicate this. Thanks, Maker. I'm a organic chemistry teacher can help you 1% of your relevance. Thank you, Cheryl. That's really nice to say. That's really nice, thank you. I'm glad I could help. I wish I would know more about topics so I could explain better. But unfortunately, this is kind of my entire knowledge. My entire knowledge on hybridization comes from quantum mechanics, which means that theoretics-wise I can explain it fairly well, but practice is really where I lose everything, because, my goodness, I have so much useless knowledge in my head. Here's what we'll do. We will create 2 icospheres for now. That is it, just 2 of them. And it's gonna be quite rough. 2 icospheres. They overlap right now, which is why it's pitch black. So we're going to randomize their positions. Set position, random value, to be a vector. Never mind, they're just pitch black because I messed up. store named attribute brightness 5 e-color. Set the color to, I know, white for now. It's fine. Okay. Now what we'll try to do is nice delta time on the left and skip on the right. Oh, does it apply to every single frame? So for example, if we do transform and then vector math, multiply delta time and then do, I don't know, 0.0 or 0.1 for now on the z coordinate, then they should just go up as animation goes on, right? Yes! And then we take a boolean, plug it in, they no longer go up. Okay, got it. That's simple. Right. So this is just enabled simulation. And then I'm guessing we can pre-bake it and such, but that will be fine for now. Then what we'll try to do is the simplest possible simulation in existence. Well, not the simplest, there are simpler ones, but like simplest for our purposes. That's because we'll try to make it so that these two icospheres attract each other with gravity. If we can achieve that, then expanding it for more icospheres should be trivial. But that is only if we can achieve that, which, not gonna lie, could get pretty rough. Okay, so what we need to do is take this and basically repeat. We're gonna have an integer because we have only two of them, and we're basically going to repeat for every single icosphere. Yes. Then right here, plug this in, sample the index. Index being the iteration. And then what we want to do is we want to Well, just capture attribute. Is that how it works? Yeah, named attribute and just plug it in. Okay. Named attribute and let's no wait, position. Yeah. Vector position. And then what we'd like to do is vector math, add this multiplied by, let's say, some kind of gravitational constant. We're gonna do 0.01. The amount of effort I am spending just to make this comically short animation. Oh, right, whatever. The point is we plug this in and then nothing is happening. Damn it! Damn it. Are they swapping places? How would I know? Okay. Not gonna lie, this sucks. And this could be wrong for so many reasons. I need some kind of simpler test example, because in this case I don't actually know if like why nothing is happening to them. That is the issue. Theoretically, we should repeat Oh, that's why. Is that why? I haven't no clue. No, that must be why. So shouldn't they be moving downwards? It's flickering. The only question is, why is it flickering? Is it flickering just because it's rendering? It's because it's detecting a change, even though that change is non-existent. Changing to one won't help, yeah. What we effectively try to do here is we're trying to get the position of every single icosphere, multiply it by a gravitational constant, and add it to everything else to create an average. Yes. If only it worked. Instance? Oh my goodness! Oh! Okay, progress! Progress! Yes! Yes! Okay! Progress! Progress, in fact. That's because now what, well, progress doesn't mean it's can work even, but it's something, because now what happens is they are moving bottom right because they are on average bottom right. As you can see. Yes! Okay, something. Jeez, this is rough. This is so difficult. Okay, brilliant. Now, what we need to do is... It's really difficult. The issue here is that we're changing the way this data functions, effectively. What we would need is we would need to get the... We need to add it all in, and then we would need to... This would give us like the average position. Yes. That's not a good way to do it. This gives us an average position of all of them. So a center of mass. And we could just have them go to the center of mass. This wouldn't work like gravity. In order for this to work like gravity, we'd... Actually, maybe we would need velocity, acceleration, and all that regardless. Yeah, fine. Let's... whatever. This is really difficult. But I can pull it off. For now, let me on the very beginning add in store named attribute. We already have position. Then we're going to have store named attribute, a couple more, which means mass, which we're just going to set to 1 for now. Then we're going to have charge, which we're also going to keep at 0 for now, because that's for the future. Then we're going to have a vector, which will be the velocity, and then a vector, which will be acceleration. Brilliant. Velocity and acceleration will both be randomized. The only difference being that this time we want them to be like fairly more normal. 0.1. There we go. Brilliant. And then for every single time step, we want to take the delta time and what? Well, store named attribute, acceleration, no, velocity. We want to update the velocity and then we want to update the position. We update the velocity by taking delta time and then capture attribute acceleration, which is a vector, plug it in, multiply, and then capture another attribute in the same node, which will be velocity. There we go. And then add like this, like this. Yes. Let's delete this for now, because it's complicating things quite severely. Capture attributes. Yep. We repeat the process, except this time... No, don't transform, that's idiotic. Oh, that was the issue, I was doing transform. No, set position. Yes. And this time we're only trying to capture velocity. And then multiply add. No, we don't even need to add it. We can just multiply it by the delta time. Do I need to capture it? Or can I just plug it in? I'm pretty certain I can just plug it in actually. Offset. Yeah. I'm actually fairly certain this would work. And that's why you should never say that's why I should never say this. Okay. So it doesn't. That's fine, whatever. Let's change it from random for now to just a velocity of 1 going upwards. Okay, brilliant. Why are you like this? Why are you like this? Sin attribute has to be acceleration added to the velocity. Then we take the velocity. Right here, multiply it and we offset the position by it. And this does absolutely nothing. Maybe capture attribute is the way to go. I'm gonna lose my mind. I am just straight up gonna lose my mind. We get 0 out of this. We get 0 out of this. Okay. What happens if we just plug in the velocity on zone? We still get 0. Well, that's curious, because I specifically remember... Do I need to store it on instances? I imagine I need to store it on instances. Yes! Goodness gracious me. There we go. We have velocity of 1 going up. Let's have now the acceleration of minus 0.1 going down. Let's see what it looks like. It doesn't look like much. They still appear to be going up at a pretty consistent pace. They do not appear to be slowing down in any way, shape, or form. Great! Oh, because we're actually... Yeah, okay, instance. Yeah, there we go, now it works. And now we're gonna fold the ground. Okay, brilliant! I'm losing my mind. This is so comically difficult. Hold on, I'll be right back. I'll be right back with you all. Okay. I'm back. This is going to be such a pain. But the point is, right, the nice thing about it right now is that we can actually in fact plug these in, and we can then just increase the number of icospheres. And there we go, it works. Brilliant. Now let's copy our setup from the 5D chess video. This time in Blender, so it will be much better. And in order to copy that setup, what we need is... Oh, we'll need to do collisions anyway. Damn it! Well, that's rough. That's really rough, in fact. Okay, first let's try the simple collisions, which is collisions in the box. That's what we're going to do. Okay. In order for this to work, before we do this, we need to check if one of the directions is greater than x, and then with this, we want it to just go the other way. Yeah. Okay. Which means we just go in. Do we separate the position? Separate XYZ position. Imagine so, then do it separately on each one for the box. For the actual collisions, we can actually do something better than we did with the, well, I think slightly better at least, than what we did with the 5D chess video, because we can just do vector math, the equation, and that should result in more accurate, I think, collisions. But in this case, math greater than, and obviously also right here, absolute greater than whatever box threshold is the 1 for now. And if any of those is actually greater, then what we do is we take the velocity or acceleration. I imagine velocity. We take the velocity and we just invert it. Wait, hold on. Now that this works, actually, can we replace the captcha so that we don't have to capture it? Because not gonna lie, that would be... Oh, we can. Brilliant. We don't need this anymore. There we go. Which means in this case we can just take velocity and multiply it. Such pain. right here, velocity, also separated XYZ. No, combine. There we go. Combine XYZ. Then vector math, add 1. This give us a domain of 0, 2. No, wait, 1, 2. So multiply by 2. There we go. Then subtract 1. This gives us domain of -1, 1. Which means then, if this is greater, then we get a 1. Means we actually want this to be less. That'll be just easier. We could also multiply by -1, but we're not going to, because then we just multiply the velocity. So, and okay, fair point. I guess I didn't think about it. If they are outside the box, okay, let's increase the box size to like a 3. It is still possible that they get stuck on the box and just keep looping back. But for now at least, they seem to be doing fine. Cube. And then the size of the cube is this. This is the size of the cube. And so then what we do is we just join geometry like right here. And being that right here we want alpha to be 0.9. And then this math multiply by 2. Then we've got a quite nice screensaver, I would say. So brilliant, we have this. And then what we could use is... What could we use? Well, the collisions in between them is the next step, isn't it? That is a problem, and a pretty big pain. Because in order to check for collisions, we need to get back to this right here. Ain't easy. So, what we would like to do is... Oh, we do get for every single one of them separately. Oh, that's nice. That's really nice. So this will be the center of gravity. Ah, but we don't want the center of gravity, do we? Wait! This doesn't have to be all that bad. This doesn't have to be all that bad at all. Okay, first let's try collisions, because I feel a tad bit more confident about the collision script. So, when it comes to the collision script, we take these, we check for each and every single one of them if the position, if the distance, yeah, so right here we get the position of the icosphere we're checking. Means we should probably have one more thing that would be like radius. Let's do radius for now. Then scale instances, yeah, and then named attributes. Brilliant. Okay, splendid. Which we could also give actually a random value. A 0.1 to 2. Because why not? Ooh, you keep scaling them. Okay, fair point. Right. Let's not. How about that? Let's not scale them. Okay, brilliant, that's a start. Then what we want is we want to take the position, named attribute float a, and we want to see if this plus the radius oh, it's because the thing is scaled down. Alright, 0.01 to 0.5. 3, and then right here let's do 1. Brilliant. Okay, that's a start. That's certainly a start. We have something. This is such a pain. Absolutely. Did I mention that I'm doing this entire thing for like a single animation that will probably be on the screen for, I don't know, 30 seconds? Okay, I'm fine. Okay, I'm fine. Now, up here at the top, we repeat for every single one. We get the position. We check the distance between position. Yes. Distance between position of the icosphere itself with the current double checking. I don't know how to animate scenes like this. Blender is free, go for it. In my opinion, go for it. Okay, if this distance is less than, we also need another sample index, because in this case what we need is float and then named attribute radius. If this is less than sum of the radiuses, or radii, whatever, that means they are colliding. And so if they are colliding, then what we want is, oh my goodness, the equation from the last video. This is such a pain. Do I even have that equation saved anywhere? I don't know. Oh, I just got a message. You know what, everyone? I am so sorry for such an abrupt ending, but I got a bit of an emergency. I am so sorry for such an abrupt ending. We'll get back to it soon. When I'll be back, hopefully I'll have figured all this out, and then also the other animations. Hopefully we'll just move much further animations in general. And for now, that'll be it. Thank you so much for watching, and have a great day.